Hello everyone, today we are presenting our case study on the usage of mechanics in real life. We choose basketball because it involves many concepts of mechanics such as Newton's law of motion, projectile motion, work done, energy and power. In this case study, we will investigate why a player keeps missing shots and how mechanics can help improve shooting accuracy. Now, I will explain our project goal. We have three project goals. First, to study how Newton's law of motion, work done, energy, and power are applied during basketball shooting. Second, to determine how force, angle of projection, and initial velocity influence the basketball trajectory and the success of a shoot. And lastly, to recommend an effective shooting technique using mechanic concept to improve basketball shooting accuracy.
That
Amira, just leave every shoe. What happened to you?
I don't know lah. I practice every day, but I still can't.
I think maybe it could be, it's not just because of your practicing hardly. I think it's because of scoring technique. Let's investigate this problem using mechanics.
The purpose of the case study to identify the factor affecting shooting accuracy and to determine how mechanics can solve basketball performance.
Amira, show one more time. We want to observe your movement carefully. Amira, I think you use too much force.
Oh really? I thought stronger force can help the ball into the bucket.
Force is important, but it's not just only matter. The other factor to score is scoring technique and also motion is also important.
Now, let's discuss about Newton's law of motion.
Now, let's apply Newton's second law of motion. Newton's second law states that the force acting on an object is equal to its mass multiplied by its acceleration. The formula is F equal to ma. In this case, the mass of the basketball is 0.62 kilograms and the acceleration is 8 meters per second square. Next, we substitute the values into the formula. F equal to 0.62 multiplied by 8. After multiplying the values, we get F equal to 4.96 newtons. Therefore, the player applies approximately 4.96 newtons of force to accelerate the basketball during the pass. This shows that a greater force produces a greater acceleration, causing the basketball to move faster.
Okay, Amira, let's try this technique. You have to make sure at the higher angle, okay? Like wow, you did it! It looked much better than before.
The basketball follows a curved path through the air. This motion is called projectile motion.
First, we resolve the initial velocity into two components, which is the horizontal component and also vertical component. For horizontal component, Ux equal to 8 cos 45 degree and the vertical component Uy equal to 8 sin 45 degree. Next, let's find the time taken to reach maximum height. At the highest point, the vertical velocity in bracket Vy becomes 0. Using the formula V equal to U plus AT and solving for T, we get exactly 0.58 seconds. Now that we have the time to reach the peak, we can calculate the maximum height, which is Sy. We use the vertical displacement formula S equal to Ut plus 1 over 2 AT square. We substitute our time of 0.58 second and use negative 9.81 meter per second square for gravity because it acts downward. Function that into the calculator gives us a maximum height of 1.63 meter. Finally, let's find the total horizontal distance, which is Sx, also known as the range. Since the flight path is symmetrical, the total time in the air is double the time to the peak, which gives us 1.16 seconds. Using the formula S x equal to Ux multiplied times t, we multiply 8 cos 45 by 1.16, giving us a final horizontal distance of 6.56 meter. And that's how you solve it.
After tired, let's go back. Let's go. I think you're tired because of your body. Your muscles are doing work while moving. Every movement requires energy, and performing the movement requires more power.
Now, we will calculate work done, energy, and power involving in this activity.
Let's look at how to calculate work done. In this example, we are given a force of 20 Newton acting on an object moving it over a distance of 6 m. To find the work done, we use the fundamental physics formula. Work equals force multiplied by distance, or W equals to Ft. By substituting our value into the equation, we get 20 Newton multiplied by 6 m. Calculating that gives us a final answer of 120 J. Remember joules in the standard unit for energy and work done. Now, let's talk about potential energy. For this scenario, we have an object with a mass of 0.62 kg placed at height of 3.05 m under the influence of gravity at 9.81. Since the object is lifted to a certain height, it stores potential energy. The formula we use is PE equals to mgh, where we multiply mass, gravity, and height together. Plug in our value, we multiply 0.62 by 9.81 and then by 3.05. After calculating, we find that the total energy stored is 18.55 J. Finally, let's calculate power. Power tells us how quickly work is complete. Here we are using the work done, 120 joule, from our first slide, and it takes a time of 2 seconds to complete. The formula for power is work done divided by time. This represents the rate of energy transfer. When we substitute our data, we take our 120 joule of work and divide it by the 2 seconds it took to happen. 120 divided by 2 gives us 16 watt. So the power output for this action is exactly 60 watt. Let's conclude our breakdown of work, energy, and power.
In conclusion, basketball is an excellent example of mechanics in real life. By applying Newton's law, projectile motion, work done, energy, and power, players can improve their shooting technique and overall performance. This case study shows that physics is not only learned in the classroom, but also applied in sport and everyday life.